Okay, so the first step is to import the data from Excel. And you can use this little folder over there. You can also click File from the top and choose Import Data and choose Excel. Both will work. So for example, if I click this little folder, and that will take me to where I kept my data. Can you see that pop-up box? Okay, great. So I set up in a way that multiple windows can be shared. Otherwise, you won't be able to see it. So if I'm talking about anything that is not visible on your screen, please remind me straight away. Let's use this SPS exercise data. So if you click Open, SPSS will show you the choice. So if you have multiple worksheets, you can choose from there. And then always check this box, read variable names from first row of data. Otherwise, the first row will be treated as the first observation, and that will mess up the format. And this one, just for precaution, sometimes if you have some missing data or there's a mixed type of format in one column or for a variable, they will check, okay, if 95% of the data points are of this format, then the format will be chosen as format of that variable. So this is just for precaution. You can feel free to uncheck it, but the first one, you definitely have to check it. So if you click OK, it will give you this data. So that's the three variables that I have. Let me take you briefly through the structure or the layout of SPSS, how it works. You basically have a data view. You can see at the bottom, that little blue button, that's data view. If you click variable view, that's the place for you to change the name of the variable, the format of the variable. You can even create a new variable by put there. So for example, I will put it as 10, that's a temporary variable, and it will fill out the format as a temporary one, so default one. By default, it's numerical. And if you click data view, you will notice that there's a new variable created, and it's all missing variable value. And you can remove it. So just right click the variable, choose clear, and it's gone. You got rid of that. So this is how to navigate through this data window. And later you will have this output window as well. So we're going to see that. Our first task is to create a histogram of variable index. And if you need to create any diagram or charts, you use this chart builder. Okay, this one is sufficient for most of the cases. Don't try those advanced ones, it can just confuse you. Click chart builder, and that will give you this window. So there's a lot of choice already. Choose from here. So if you want to create histogram, click it first. It will give you some choice. And don't choose the fancy one because we just need a standard histogram, so a simple histogram. And if you choose other ones, they will tell you, okay, this is stacked one and this is a frequency polygon, but you need to know what you are doing. I would recommend you stick with the standard one. So this is a standard, double click it, it will show you this template right there. This is your drawing board. And you can, so for example, if you want to create a histogram of variable index, what you need to do is just click this index and drag it to this x-axis. So that will give you some idea about what you're going to get, but this is not the real data. The real data will be different. This is just some illustration, and you can check this display normal curve that will impose a normal curve on top of the histogram based on the mean and standard deviation, simple mean and simple standard deviation. So this is what you want, and you just click OK. That will give you this output here. So that's if you check the handout that I post online, so that's exactly the same. And that black curve, that's a normal curve, is calculated based on the mean and standard deviation shown on the histogram. So this is how to generate histogram. Similarly, if you go to the same place, click graph, chart builder, you can complete task C by generating a scatter plot. So once again, if you click scatter over there, it will give you a lot of options. Just choose the standard one. So double click it. It will put this template on top, okay? And then you can, so for example, I will put GDP here and index in the y-axis, and there's no need to change anything, just a default scatter plot is fine. So that will give you this scatter plot. So you can change the axis if you wish, but the pattern will remain the same. So this is how to generate a scatter plot. Then the next step is to generate some discrete statistics of those variables. So now we are performing statistical analysis. You click this analyze. most of the, if not all, of the statistical analysis are available from this drop-down menu. So we're generating descriptive statistics. Just go to descriptive. So descriptive is for numerical variables, continuous variables. Frequency is for categorical variables. So you have discrete categories like T or gender. So we choose choose this descriptive, and then you just put GDP and index, those two numerical variables. In SPSS, they use a little ruler to indicate that's a numerical variable. And if it is those balloons, that usually means it's categorical variable. You can also click these options that will show you all the statistics that are available. So you can tick all those boxes if you like, okay, whatever. Usually those are not useful because we don't have to check the distribution of those variables at this stage. So you can click continue and click OK. That will give you the descriptive statistics of all the variables that you need. This thing, I mean, the output over there looks like is a picture, but it's not a picture. So if we double click it, you can edit it. And you can actually select all. You can select this and copy and paste it directly to Excel. It's 100% compatible in Excel. So you can rearrange the format either in Excel or in Word document. All you need to do just to double click it. Even if right click, copy it and paste to Excel. In most versions, it will be treated as a table instead of picture. Okay, but if you want to copy a picture, you can choose copy special. So that's, you can copy it as an image, then you paste it somewhere. But in most cases, unless it's this kind of histogram or scatter plot, for tables, you want to copy it as text, then they can edit it. But pictures, I mean, those graphs, you can copy them as picture. Okay, that's descriptive statistics. How about categorical variable such as T, because T equals to 1, 2, 3, indicating the 3 periods in our data set. So you can click this frequency, so analyze descriptive, but the first one, frequencies. Now we are only interested in T, and you can check what kind of statistics that you can have. So for example, you want to have all of those statistics for it. You can check them, and you can also have some chart output, so bar chart or pie chart, histogram. So if you can click continue and click OK, that will give you the statistic that you requested. Okay, that's the statistics and frequency count by default, and a bar chart showing the frequency count of those 3 categories. So this is how to generate descriptive statistics or frequency tables for categorical variable. So the next task is to create variables or transform variables. We go to this transform and use the compute variable. Usually this is what you need. There are multiple ways to complete the same task, even within SPSS. I'm showing you the most commonly used one. So if you are a very good user of SPSS already, you can feel free to explore other ways of creating those variables. So for example, here, we would like to create the squared term of T, and we would like to perform a log transformation of GDP. The way to do it is to click this transform or compute variable button. Target variable is the name of the new variable. So for example, that's T2. And in this box, you put in the equation, the formulas for to calculate that. And that is T, you move it to there, times and T again. Alternatively, just type like what I did, T times T. That works as well. So if you click OK, it seems like nothing happened. No, actually, you have one more variable. So if you go back to the data window to check data view, have you noticed that you have a T2 here? And if you check this value, that's exactly the square of T, the original variable. So this is how to create a T2. And log transformation will be the same thing. So for example, we use this ln GDP as the name of the variable. So you can use ln bracket GDP. Alternatively, you can even find those formulas in this box. So you can click different categories functions and find the functions that you need. So there's 2 ways of doing that. If you know which function that you use, go ahead, just use it as what I did. If you have no idea, you can check. So arithmetic, we have this long transformation. So you can click this little blue button to move it up. Then you put GDP inside that set of brackets. That will do. Okay, you can either type or select a variable, the functions from the list. So either case, you click OK. So once again, you have a new variable calculated there already. That's the natural log transformed GDP. So we have those two variables ready. Now we can go ahead to analyze the regression model.
Sorry, can I ask one quick question?
Yep.
You were at this compute variable folder, and there's this if possibility. What is the clause I put between if I want to have like a range? So if it's between this number and this number, how do I put that into the if?
That will be covered later. Later
Okay.
on, we need to, for example, we would like to create a dummy variable that equals 1 for a certain value, but 0 for the other type of value. We have this if. If you click the if, that's where we need to put the condition in. But we will cover that later. Very soon. Okay, good question, because that's very
I asked a question in the chat. Why did you decide to create here a T2? Is it just to show us how to do it, or there is a reason why you decided to?
Oh, it's just to show you how to create square term, how to create variables for illustration purpose. Okay. Oh, I noticed that we have a question in the chat box about the use of software. Is it all right to use R for exam? That's perfectly fine. Any software will do. The one that you feel comfortable will fine, because we actually do not require you to submit your code or the way that you generate those results. So anything that works for you will work for the examination. Okay, let's come back to the question we were working on. So that's question G. We need to estimate regression model. So if you click regression and choose linear, that's where to find this window. So we need to move the index into this dependent box, because that's the dependent variable. Then we need to move the variables that we need to include. So we have a GDP. If you read the question carefully, we have a GDP, T, and T2. Those are the three variables we need to include as independent variables. So we move them into this box. Then that's it. At the moment, you do not have to use any of those buttons on the screen. We'll use them later. This is just a quick demonstration about how to run a basic linear regression analysis. So if you click OK, that will take you to this box. And that's essentially the same thing if you use Excel. You have R squared, you have this F test, and you also have coefficient estimate, T test statistics, and P values for those variables. And you may notice that both T and T squares are not significant. Okay, so this is the linear regression analysis. By the way, while I'm demonstrating, if I go too fast at any point, just shout, okay? I can slow down or repeat what I mentioned. Okay, so that's step G. Next question is to use stepwise backward and forward selection method to determine the best set of regressor to predict the value of index. So we need to run, actually we need to estimate the same regression model, but we need to consider all the variables available. So previously we didn't include long GDP because we don't know which one we should use. So if we put all of them into this list, that basically means that's everything that I have. Those are all the independent variables available so far, T, GDP, and two transformed variables based on T and GDP. So if you click this button, notice there's a method. The drop-down menu, you have stepwise, remove, backward, and forwards. Most people, if not all, use stepwise only. So that's the best procedure. So I'm going to show how to use that stepwise. If there's any discrepancy between among those methods, we go with a stepwise, put this way. So if you choose stepwise, you can click OK, and the software show you, okay, so for example, this is a start. Variables entered and removed, it shows to you, it took 2 steps for the software to reach the conclusion. This is the best model that I can find based on stepwise selection algorithm. And in model selection, model summary, it gives you the model summary of both models, the first one and the second one. The first one includes GDP only. The second one, T2 enter, then it stopped. Okay, so that's the R square, and you can see the improvement.
Sorry to interrupt. And if this isn't helpful to the rest of the group, go ahead and say so. But I think it would be helpful, at least to me, to understand a little bit more about what these readouts are kind of telling us. Like kind of, so what exactly we're looking at from these readouts. Does that make sense?
Yeah, yes, I will take time to explain to you. So for example, here, there are two steps. First step, GDP entered. In the model start with GDP. And the second step, T2 entered. So variable entered and variable removed. And then in terms of model summary, it gives you the model summary for both models, not just the last one. So first model and the second model have R squares. And this part, that's for two models as well. The reason to choose stepwise, I have a question from the chat window. The reason to choose stepwise, because empirically, that's the best way to do variable selection. And the limitation of backward and forward selection have been discussed in our lecture. And I actually point out, we use stepwise in practice. And the software gives you those options you can try, but when they have discrepancies, choose stepwise. Okay, so the outputs are actually the same. The layout is exactly the same as a standard regression analysis. You have seen this many times in my lecture. The only difference is it gives you the models for every single step. If there are 7 steps, you will see outputs of 7 sets, 1 for each model. So here, if you have 7 models, 7 steps, it will give you 7 ANOVA table. They all stack together. But we're lucky we have only 2, so it's easier to rate. In terms of coefficient, you do have 2 models. The first model has GDP only. The second model has GDP and T2, 2 variables. That's it, it stopped. Only 2 steps. And you have a B, SD, standard coefficient, T, and the p-values for all of them. And you may notice that the reason that it stopped is because all the variables left in the model are significant at 5% level. And none of those existing, I mean, those excluded variables are significant enough to be added. So that's why they're excluded. And if you want to know more, you check this excluded variable. And you notice that the significance are given over there. So they are, in the first step, so T2 is still okay, so it's added. But the second step, the 2 variables T and the ln GDP that are not included, have a look at their significance level. They're very high. That's why they are not included. Okay, so this is the stepwise selection process. So you have your model. What you need to do is just to go with the last model. The software gives you every single step, but anything before the final step or the last model are intermediary. Those are the less perfect models that you have been through in order to reach the last one. Okay, so go with the last one. And the additional information just for her information. Okay, so this is stepwise. You can try backward and forward selection. They usually end up with the same model, but if they are different, usually the stepwise one is the cleanest one. If you, yes.
Sorry, one question on that. So I understand that this is a good process if you have no idea about the underlying dynamics of a subject, but like, for example, when you look at the housing market, we do have quite a large literature of like pre-selected variables that are like almost common knowledge, right? Common knowledge variables. And so do we prioritize model selection through stepwise, or do we prioritize keeping in variables which from the literature just make sense to keep in?
Okay, that's an excellent question. As we stressed, emphasized in our lecture, stepwise can only be treated as a starting point. And your judgment, your understanding of the literature, your understanding of the market is always much more important than the stepwise result. And you can actually force some variables to stay in the model. So for example, the focus of your study is the size of the property. And you may notice that size of the property are highly correlated with the number of bedroom and number of bathroom. Maybe for some peculiar reason, when you run it stepwise, only the number of bathrooms is left. But that variable is highly correlated with area. You can decide to remove the number of bathrooms, but keep the area. Once you remove the number of bathrooms, area will be significant. They're highly correlated. But the model may be slightly worse than the one with the number of bathrooms in terms of R squared, but really marginal. But for your analysis, based on your understanding, this is a better model for me practically, then that's entirely fine. Okay, so based on that note, let me just go back to show you something.
I have a question. So from the past lecture, I remember that some of the dummy variables, for instance, wouldn't be significant, but then that'll be okay because the whole thing is significant.
Mhm.
For the stepwise method, does it take out the insignificant dummy variables? And if so, do you have to still put the dummy variables?
That's an excellent question. You are thinking just one step ahead of me. So this is what I'm trying to show to you. So if you can see this box in front of you, did you see there's a block one of one? Okay. If you put that group of dummy variables as one block and choose enter for that block, then you move to the next and put everything else in this block, choose stepwise. So the first block, so for example, if you go to first block, I put T and T2 in one block, which means they have to be kept as one block. Then the next block, I put GDP and ln GDP into the entry stepwise, which means for those variables, do a stepwise. This is the way to keep those, a group of dummy variables in or out of a model as a group, okay? So for example, here, if we click OK, and you can see the final model will include, so the first one will be T and T2. It's required. You have to use it. Then between GDP and the ln GDP, GDP is included. So even if T and T2 are insignificant as a group, I mean individually, you still include them because it falls into it. So this is the way that you can use SPSS to deal with a group of dummy variables. Just use that block. Okay, I have additional questions from the chat box. If you would include T2 squared, would not you also always include T? Well, this is for the illustration purpose, but if you want to include T, both T2 and T, T2 has to be significant. When T2 is significant, we include all the lower terms. But if T2 is not significant, you have to go back. So you can choose either to include T2 or T. That's a good question. Next one, and by last one, you mean the second one? Yes, for this exercise, that's the last model. That's always the last model in this box. It could be the 7th, it could be the 8th.
Professor,
Okay.
I have a follow-up question on stepwise. Sorry to be
Sure, go ahead.
annoying with more questions. But doesn't stepwise selection also depend on the number of observations? Like the optimal model that is selected by stepwise is a function of the number of observations as well, right? Like if you have more observations, then likely more variables are going to be included, even though they don't explain so much of the dependent variable. And then if I only have few variables, probably it's going to select a very narrow model, but maybe I would like to show that another variable that I could be using makes a difference, just like because of the small sample size, the stepwise wouldn't include it, but still I include it because I know with a bigger sample size, it would definitely make a difference. Does that make sense? Or is that completely wrong?
That's a very good observation. All else being equal, a larger sample size will always give you a higher chance to identify significant variables, simply because n is just part of the denominator for that t-test. You can argue that it might be, but you cannot know for sure. If the relationship is not there, it doesn't matter how big the sample size is, not going to be significant.
Yeah.
So to answer your question, the common practice in research is you present two sets of results. The first one is regression result with everything, all your variables, the so-called full model. Then you present a clean model. So people kind of have some idea, if I include everything, what it's going to be like. But if I exclude those insignificant ones, this is the clean model, that's what I have. That sort of solved the problem.
Okay, thank you. You're welcome.
Okay, so the next one is to generate a scatter plot between the residual and the GDP for a model that we need to estimate again. So this is an important technique to learn, because we need to deal with residuals or analyze residuals. So what I'm going to do is to remove this block first, And I am going to re-estimate this model, because if you read the question carefully, we need to estimate this model, then generate the residual for this one. So the dependent variable is index, and the two independent variables are T and GDP. This is for illustration purpose. Okay, right? No reason, just for illustration purpose. I'm not saying that this is the best model. Okay, so this is the model that we need to start with, and now you have to click the save button, because you need to save the residual into the database automatically. So check this unstandardized box. That's the residual. That's everything that you need to do, which means this just the original residual, the difference between y and y hat. We call it unstandardized. So if you click continue and you click OK, and then you go back to your data file, and you may notice that you have a new variables created. It's called res_1. So that's the first residual series generated in this database. And then you are ready to generate that scatter plot. So once again, you use the same chart builder, and we have the scatter plot over there. But this time, of course, we are not going to use those variables. So you would like to plot residual against, so for example, GDP. Let me see. Yes, residual against GDP. So residuals on the horizontal axis. GDP is a vertical axis, and GDP is a horizontal axis. So click OK. That should give you this scatter plot, which shows, I mean, this is not an ideal model because there's a pattern. Okay, question.
This is a really simple point. Can you quickly restate the difference between the unstandardized residual and the standardized residual? Thanks very much.
Okay, sure. So if we go back to that box, if you click save, it gives you all sort of different residuals. For this module, for most of the analysis, ignore the rest. For example, standardized one is standardized. The mean is 0, the standard deviation is 1. Okay, and the unstandardized one is the original one. It's just y minus y hat, exactly what we want. In most 99% of chance, if not 100% of chance, you use unstandardized. Okay, so let's go back to our exercises. So we finish exercise I. Exercise J is to perform a wide heteroscedasticity test on the model index, and index equals. So we are still using the same. We're still using the same model, so the same model that we estimated. So let's go back.
Sorry, one more question on the histogram.
Yeah.
So if we identify a big outlier there, which, like, let's say the point in the top right corner.
Yeah.
Would it be sensible to, as a robustness check, just exclude that one observation to see whether this one observation has a big influence on the results of our analysis? Okay, that's a very good question. Data cleaning is actually discouraged during the analysis, because you will be tempted to remove the one that do not behave and kind of twist the fitting of the model. And there is a reason for it. I wouldn't call it outlier. It's only indication that our regression model is not adequate to capture the pattern for that particular observation. That might be due to missing variable, but some other aspect of this model of this observation should be fine. So data cleaning or the identification of outliers should be completed before you start this kind of analysis. In some rare cases, you later identify as an outlier, but that's only indication. That's an indication that data cleaning was not adequately done before the start. But when you say before the start, that doesn't mean before we get the data, but when we have the data.
No. Before you start descriptive analysis, before you start regression analysis.
Before we start regression. So in the descriptive part.
Right. You can do some data cleaning, get it ready for analysis. But once you get started, after regression analysis, those 2 points actually is quite difficult to forecast. Let's remove them. You may be tempted to do something kind of naughty, just to twist the model to behave. You see what I mean? Yeah. Okay. Let's say we have like 2 villas in our data set that cost like 2 billion each. Oh, those probably should be removed at the beginning. Yeah, that's what I mean. Removed at the beginning, not here. So that's why I said, if you have to do that halfway through your analysis, that's the only indication that you haven't done a good job. Perfect. In data cleaning. Thank you. That answers. Okay, so it's not like banned or forbidden, but we try to avoid it. You don't want to accidentally overlook something. Okay, we have questions. Are we expected to scan for and remove outliers in the exam? Yes, you search, check the data, because you do need to run some sort of this exploratory plot. The reason for us to see this histogram and descriptive analysis is to see whether there's anything abnormal. You have some basic understanding of the structure and the content of the data. So if you see anything that is clearly abnormal, for example, a house is sold for only 10 pounds, then there's no rational explanation, you have to remove it. Yeah, okay, so good question. Okay, so our next step is to perform a wide heteroscedasticity test. So to test this, we need to generate the square of residual, because that's the dependent variable of our analysis. So we do the same thing. We can create this variable we called RESI2, and that is simply just the square of this unstandardized residual. So that's RES1 squared. So if you click OK, you will see this new variable in the data view window. Next, we also need to create the additional variables to be included in the test model, because the test model uses the square of residual as the dependent variable, and right hand side we have the independent variables and their square terms and the cross terms. We just want to check whether any one of them are related with the square of the residual, which is sort of the estimation of the variance. So what we need to do is to keep computing those variables. So for example, we have a GDP2, so that's the square of GDP. We have T2 already, but we don't have this one. So that's the GDP2. We also need to create a cross term. So that's the product of GDP and T. So we call it GDPT. That simply is GDP times T. So that's the formula to create those variables. So if we go back, you may notice that we have a residual square, GDP2, GDPT, T square, and GDP and the T, those are the original variables. So those are all the variables that we need to perform this test. So the way to estimate that regression model is click linear. We're not going to use index as the dependent variable. The test equation for a white test is the residual square equals to all the independent variables, their square terms, and their cross terms. Okay, so this is the test. And keep everything. There's no need to do a selection. So just click OK, and that will give you this regression result, and it shows to you the F test is significant, which means at least one of them is significant, and that's the indication of heteroscedasticity. So we have a question. I saw that a coursework required us to submit an Excel sheet. If we compute SPSS data, how do we submit that? Oh, the Excel file, it should contain the final data set that is used to run your model. So you do need to do some data cleaning. You need to transfer some variables, create some variables. So you include that data set in your Excel file. Outputs are optional. And as I mentioned, if you copy and paste the result into Excel, that's the table. So if you really want to include them, it's okay. But you will need to summarize your outputs in your reports anyways. So including those original outputs are optional. But including the data that you used to generate the result is important, because I may need to use your data just to see, by using the data that you generated, whether I can get a result. Okay, just seeing a result actually gives me no value, because you need to summarize them and include the finding in your report anyways. So did I answer your question? Okay, great. Now let's come back to our analysis. So the conclusion of this test is, you may notice that in my handout, I give you the test equation. And I also conclude that, okay, based on the F test, we do not reject the null hypothesis, which means at least one of those variables we included in the test equation is significant. That means the variance is not constant. It changes according to the value of some of those variables included. That's another way to say we have heteroscedasticity. So this is the result of the white test. Okay, any questions about this test?
I have a question regarding this test. So it means if we have like 8 variables, like in the exam, we have to create all the intercept and all the squares to do the test?
Yes. This is where, that's a good question, by the way. This is where stat are more efficient. But if it is just for one coursework, and you may notice that we do not have that many variables, and not all of them are significant. You're supposed to use significant ones. So it's not going to be that overwhelming. Definitely it's doable within an hour or so.
Yeah, and sorry, one quick question on that also. If I have in my regression model before an interaction term already, I don't have to interact that interaction term with the other ones, right? So that I have 3 variables then. That's not necessary, right? I'm
not quite sure I can catch up your question, because the first part, the connection was not very good. Could you please repeat?
Sorry yeah. So in my regression model before, I have an interaction term already. Do I then need to interact all of the other variables with the interaction term also?
That's a good question. Yes, every variable is included in the model that you are testing. The interaction term actually is a new variable. It's variable of zero. So you treat it as a variable. Okay, so on that note, you perform this kind of a test on a model that you feel like this is probably the end of it. I can stop. Let me check whether it's adequate or not. You do not do that on every single time. I mean, even if you have a model that you're not entirely happy about, what's the point of carrying such a test? So only when you reach to a point, you think, okay, that's probably the time. I exhaust all the ways to, I mean, this is the best model that I selected. Let me check whether you can pass this test. That's when you need to do it, okay? Not every single step. Next question. You do the test after completing the regression model or before completing regression? Well, I think I just answered that question. So not just after you complete a regression. It's always after you run a regression model, then you perform a test about that model. So in this case, that's a regression model with a T and a GDP only, 2 independent variables. In your analysis, you should carry on analysis of variable selection and look at the logic, or whether the variables kept by the computer make sense or not. Then you juggle it and you change it. Then you're happy about the model. You want to stop. This Y test and the other test is a check to tell you whether you can stop or not. If the model cannot pass the test, you go back to further improve it. Or if there's no room for improvement, for example, the Y test, doesn't matter how you change, it will not pass the test. What can you do? You can request the so-called standard error test, or if you, I mean, the robustness, the heteroscedasticity robust standard error. So I showed how to do that in my PowerPoint already. So that is a request by Stata, can be automatically requested. However, in SPSS, that's not an option. It's not as straightforward. Okay, so that's some area. In case you need it, you will find as Stata is better than SPSS. Okay. So let's go back to question.
Yeah, sorry, I don't know if this question will make sense, but I just wanted to ask for interaction terms. So assuming you had 3 independent variables, A, B, and C, would you then create interaction terms like A to B and A to C, and then B to C, so that you essentially have all iterations of them? Is that how it works? At no point where you have a variable that interacts with 2 other variables. It's just going to be all possible combinations of
it's all possible
one with one
combination, right? So if you want to explore, but usually we don't do that. This kind of aimless. Usually you are not that clueless about what's happening. As I mentioned many times in my lecture, you create interaction term for the purpose of testing a hypothesis or answering a question you want to ask, not just blindly try to see which one by chance will be significant. Because even if it's significant and you do not have an explanation, you're creating some trouble, particularly when you're dealing with a small sample size. I mean, it may be by chance it's statistically significant, but it's economic, it's a nuisance. Okay, next question. Did I understand this correctly? If you have an interaction term in the model, you have to cross this term with the other variables in the heteroscedasticity test. Yes, that your understanding is correct. If the model that you are testing contains an interaction term already, you treat it as an independent variable. So you cross it with others. Okay, so did I answer your question about the interaction term? When you do tests, of course, you have to create all those possible cross terms. But when you do analysis, we usually do not create those interaction terms without a very good reason. Okay, that's white test. The next one is reset test. So once you know how to perform this white test, performing reset test is not that difficult because you do need to, so this time we need to create the predicted value. So like if you go to compute variables, and we need to create the predicted value of y. So the first step is to run this regression model. So this time we will use T and GDP only. And because that's the model we need to estimate, and the dependent variable will be indexed. So this is the one we would like to check whether there's any model misspecification. So perform a reset test. So if you click statistics and sorry, not statistics, save, we don't need residual anymore. We need predicted value. So the difference among those is, once again, the predicted value is just unstandardized one, is the straightforward one, y-hat, calculated based on the regression model we have just estimated. And then ignore others, you don't need them. Okay, because we just need y-hat. That's what we request. So check this predicted value box, click continue, and just estimate this model. It will give you the predicted value based on this regression model. So just for illustration purpose, let me get rid of those. So it's easier for you to see. I can clear them. So there you have this PR1. So that's the predicted value based on the regression model using these two variables. And you can see that's the difference between the predicted value and the index. That will be the residual, okay? So we have this variable, and the next task is to create the squared and the cube term of index. So the first one will be index 2, and that will be the square of this unstandardized predicted value. So that's the square of y-hat. Click OK, and you have this new variable. That's the square of this PRE_1. Then the next variable will be the cube term. So we call that index 3, and that will be just index 2 times y-hat, and that's y-hat cubed. So click OK, that will give you index 3. So for reset test, we run the regression model again, but we include the squared and the cube terms in the regression model. So what we need to do is to go to regression, linear. That's the model we're testing. But for reset test, we put these two in to see whether any one of them is significant or not. So that's you can click OK. That will give you this regression model. And you may notice that it shows to you, because of a multicollinearity, high collinearity, index 2 is excluded. This is not that uncommon, particularly when you have those higher order terms. So this one, that's fine, because we just need to check whether this full model is different from the reduced model or not. So in my handout, I showed you, okay, this is the full model for the test, and the model without any higher order term of the predicted value is a reduced model. So you will have those two sum square of residuals, and you can calculate F-test statistics as pointed out in my handout. So that's how to get the result in order to calculate test statistics. We have a question from the student.
Hey, that's me again. So when you're looking at the outputs, you had said, that you're looking at the collinearity, and this is a really basic question, but would you mind telling me like how it is that you're looking for that in these outputs? Because I want to make sure that I'm interpreting them properly.
Oh,
Thanks.
this one, that's a good question. This one, you really don't have to worry about that, because the software did that automatically. Sometimes this is that's a good question, by the way, because recall when we discuss multicollinearity, I mentioned that this is not perfect collinearity. If it is a perfect collinearity, you don't have to worry about that. Why is that? The software will take care of that. This is a perfect example. Here, index 2 is perfectly collinear with existing variables. It didn't show which one it is, but the VIF of or the correlation between index 2 and the rest of the variables is 1. It's perfect. So it's automatically dropped from the analysis. So that's what we have here. So the variable entered, we have index 3, T, and GDP. And somewhere it mentioned that, let me see where it is. Well, this software doesn't mention that, but in other software, it will show to you, okay, you tell me to include a variable here, excluded variable here. The collinearity static tolerance, notice that it's really high. That's scientific format, which means it's over 1 million, the value. It's too high, and as a result, it's dropped. That one is not included. That's the reason. It didn't say specifically, but it's because it's highly correlated with the rest of the variable. The VIF is too high. Okay, next question. When we choose to do a stepwise regression, do we need to cite relevant papers that support this method, or is it sufficient to not cite any paper for that because it's considered common knowledge? Well, the answer is later. It's considered to be common knowledge because it's a standard way to choose variable. So you can just use it. You do not have to cite any reference. Okay, so the next question is, yes?
Yeah, I have a question on our 2 last steps. After we did the white test, why are we not transforming the data to answer the problem of heteroscedasticity? And same here, if we have this problem with reset test, why are we not transforming, the model so it matches the answer of the test?
Well, that's for you to do. You can do that. I'm just demonstrating how to do the test.
Okay.
Once you identify the problem, and the tests are your friends, okay? You hate the fact that your model do not pass the test, but once the model cannot pass the test, it always gives you some indication about what potentially might be wrong, and you can go ahead and adjust the model accordingly until, to the point that your model can pass the test. So that's a good question. That's why we need to perform this kind of test. Okay, next question. The K in calculating the F test, is that a difference of number of independent variables between the 2 regression? Yes, the first one is. The first one is. That's a good question. Okay.
Sorry, can I ask a quick question?
Sure.
So about the reset test. So can we use this test inversely? I mean, like if we, like to regress a reduced model and without any like the higher order, can we, and it's not very significant. So can we say that maybe we can include like the quadratic term and cube term like that?
If the test is significant, the conclusion is you overlooked some high order terms. That could be square terms or could be the cross terms of your independent variables. So I think if I understood your question correctly, is if the test result is significant, you need to go back and consider high order terms.
Okay, so if we have lots of independent variables, so we have to test them step by step, right?
Right, because it has, that's a good question, because the test can only tell you some of them, one or several are important. We don't know which one it is.
Okay, thank you.
You're welcome. So regression analysis is not that straightforward. There's a lot of judgment involved and a lot of back and forth adjustment. Okay, so next one is a predictive failure test. And I would like to use this test to demonstrate how to create a variable and change the value for a subset of observations. Just go back to the question we received at the beginning of the session. Okay, so to perform a predictive failure test, what we need to do is to create a dummy variable to indicate, to help us to choose the variables to be included in the so-called reduced model and leave everything to be included in the full model. So we need an indicator to indicate which to be included in the first step. Okay, so let's create a variable first. Let's call that PRED, so predict, and we set value to be 0. So that's all 0 to start with. And if we go back, you may notice, we have this PRED, it's all 0 across the board. Next, we want to change. We want to change the value of this variable to be 1 for the last 10 observations. So we can choose to exclude them in the first step and reserve them for the predictive failure test. So that's the idea. Okay, to do that, one way of doing so is to use this compute variable. There, PRED, change the value to be 1, but please do not click OK. If you click OK, you change all the value to be 1. You click this if box, if button, and choose this radio button, include if case satisfied condition. And here, we want to set the value to be 1 for the last 10 observation. What you can do is to go to this category of, groups of functions, choose miscellaneous, and choose this case number. That's actually is a number of observation. So if it is greater than 90, that's 1. So this $ case num indicate the order or the numbers of the observation in your data set. So for example, the 90th observation, this 91, this one over there, the value of this variable will be 90. So if you click continue and click OK, it will ask you, are you going to change the existing variable? Yes, of course, we want to replace the value of this variable for the last observations only. So click OK and go back to the window, see what happened. The last 10 observations value are changed to be 1, but for the first 90 ones, it's 0. So we can use this variable as a selection variable to choose what variables to be included. So in our predictive analysis, we use the first 90 observation to estimate the regression model. Then we include everything as the full model. Then we check whether the R-square or predictive errors are the same. So if they are roughly the same, we can see, okay, the model actually can predict well. So that's the rationale behind this test. So what we need to do is to run a model with the first 90 observations only. So let's go back to estimate this model. We use T and GDP only. Here, you need to do one more thing. Put PRED into this selection variable box. That's our selection variable. That's the dummy variable we have just created. Click rule. Only when it's equals 0, that's included in the regression analysis. Otherwise, we don't use them. So if you click continue, let's uncheck those. Let me see whether we have. Yes, we do not have to say the predicted value. So just run this regression model and click OK. That will give you this output. And you may notice that in this ANOVA table, there, the degree of freedom corresponding to total is 89. That value is n-1, which tells you we only used 90 observations in this analysis. So this is your first regression model for this test. The second regression model is simply the regression model that we estimated before by using all the observations. So all you need to do is to go back and remove this selection variable, click OK. That will give you the second regression model. Notice that this total DF now is 99, which means we used all the observation, 100 of them, to estimate this regression model. So those two gives you those two regression model outputs, that the residual sum square here. This is a 1932, and you also have another one over there. It's 1743. Those are the two numbers that you find in the F-test formula in my handout. So this is to generate the regression output that you need to perform this test. Are we okay with this one? Okay, excellent. So this is a predictive test. The next one is to perform a child breakpoint test. You may suspect that, okay, maybe at certain point, I need to estimate separate regression models. So for example, I would like to check whether there is a structural break at GDP equals to 30 million, which means if a GDP is higher than 30 million, you can define it as a large economy. The regression model is different. You need to estimate regression model separately, or their intercept terms and slopes are not the same. To test this, you need a child breakpoint test. What we need to do is to first create a dummy variable to indicate this break you want to check. Then you create cross terms between that dummy variable and your independent variables. Then you run a regression model to see whether that group of dummy variable and its interaction terms are significant. Is significant as a whole. So that's a partial F-test as well. We run two regression models. So let's run the first model, but before that, we need to create that dummy variable first. So for example, we call the break that equals 0 first. So we set this and get rid of those conditions. is equals 0, so that's the starting point. You have a dummy variable created, a equals 0 across the board. The next, you want to change this value. When GDP is greater than 30 million, so for example, you have some really large, this one, that value should be 1. How to do that? We use the same technique. And you change this value to be 1, but do not click OK yet. Choose if, include if case satisfy condition. Here, that has nothing to do with a case number, but it's to do with the value of GDP. That will only equals 1 when GDP is greater than 1, 2, 3, 4, 5, 7, 7, 0 there. So it's 30 million. So if you click continue and click OK, and that will ask you whether you want to replace existing variables. Of course, you need to click OK. Then you go back, and you may notice that yes, break is, oh, I probably that value is, I forgot, that should be 7 zeros. So there's only 6. It's my mistake. Okay, so 7 zeros. Click continue, and okay, let me clean it up, because I accidentally only include 6 zeros. That should be 7 zeros. So it's 0 again. I reset it, and then go back, change to 1 only. Let me check. 1, 2, 3, 4, 5, 6, 7. Yes, okay. So continue, click OK. That should do it. It will only change the value when GDP is greater than 30 million. So there are a couple of 1 over there. That's the independent variable we would like to, the sort of a structure break indicator. And then the next step is to create this interaction term, so GDP break. That will be the cross term of GDP and break. So that's the first cross term. You want to check whether it's significant or not. That changes the slope of GDP. We do the same thing for T. So this one is T break, not the same thing as T break that we have, but you have the idea. So that's a T break. And that's the product, that's the interaction term between T and break. You click OK. So we go back, we notice that, okay, there we have both the GDP break and T break. Oh, I see. See, that's the problem. If you use SPSS, you have to be careful to get rid of this. Did you see the mistake that I made? Sometimes when I go too fast, let me go back to show to you. Did you see those missing values? This is because I forgot to remove the condition. It only replaces values when it makes this condition. So I need to go back to do the same. I mean, I have to do the calculation for all the variables. So that's difference. Can you see the difference? I changed T break. You need is to have the value. So this one, GDP break, is the same thing.
So would the best practice there be to reset each time before you take the next step?
The best practice is click reset. Yes.
Yeah.
That's a good idea. Or double check everything.
Yeah.
Always go back to see the data, what you did, because I mean, the chance for it to make mistakes is unlimited. Okay, there. So we have all the values that we need. And the next step is to run this full model. So in your full model, you want to include both the structural break indicator and its cross term with existing variables. So you just click OK. That will give you this model, and that gives you the, so if you check the F-test result that I gave in my handout, this 1478949, that is the sum square for residual for the full model. And that 1932.832 is just the output that we got from the original output without the break and without the break indicator and its cross terms. So those are the two models that you need to perform this F-test. And the conclusion of this test is we are going to reject null hypothesis and we identify there's a structure break. And how to decide on a break? This is judgment call. This is just for illustration purpose. In your analysis, you may suspect, you can, for example, you can examine the, for example, here, residual plot. And you look at, okay, before this, everything sort of clustered together. And after that, there seems to be a pattern. So maybe there is a structure break, something different between those two groups. So you may put that at 30 million there. So this is the reason that I choose the 3 million for this for this demonstration, to answer your question.
So is it related to heteroscedasticity here in that case?
Yeah, if you introduce this structure break, you may be able to solve this heteroscedasticity issue.
Thank you.
Sure. Okay, so that's a question.
Sorry, I had also a question from my side. Is it possible to create more than 2 samples? I mean, more than one breakpoint to estimate different models, such as, I mean, for example, the GDP between 0 to 50, 50 to 100, 100 to 150, etc., and to set different, I mean, maybe 4 models to estimate them?
Yeah, that's an extension of the technique we have discussed. That's absolutely feasible. It's doable. And if you have a good reason to do so, so for example, we identify this kind of this continued pattern based on, for example, scatter plot, by all means, go ahead and give it a check.
Get it. Many thanks.
You're welcome. Okay, next task is also very useful. So that is the creation of a group of dummy variables in one step. So we create dummy variables for T. In SPSS, it has a very convenient tool. It's called create dummy variables, very self-explanatory. So if you click create dummy variables, and it will show you a rather complex box. And once again, the software would like to provide you with the full package. But for us, just use the very basic, the basic one is fine. So the variables that we would like to create dummy variables for is T. T has 3 values, 1, 2, 3. So we need 3 dummy variables, 1 for each. We can choose which one to use, but we need a full set. And just keep everything as default. The only thing that you need to input here is the root name. That means, okay, how to name the dummy variables that you want to create. So for example, if I input TD here, you will have 3 dummy variables, TD1, TD2, and TD3. 1 corresponding to each of the 3 values in T. That's it. That's all you need to do. So if you click OK, and if you go back to SPSS, you will notice that you have 3 new variables created. T1 will equals 1 when T equals 1, and this is what T2 will equal 2 when T equals 2, and TD3 equals 1 when T equals 3. So that's the 3 dummy variables that you can create out of this categorical variable. So just imagine if you have for example, a time indicator that indicates 20 years, and you want to create year dummies. This is very convenient too, because you can create 20 year dummies in one go. So this is how to do it. I saw a hand raised a moment ago.
Oh yeah, sorry. I just wanted to ask, if we're dealing with categorical variables, why don't we go with dummy variables from the start? Like, what's the point in first running a regression without dummy variables?
Oh, that's just for illustration purpose. And sometimes you probably don't need dummy variable because the relationship is sort of linear among those categories. Okay, so later if you realize that you do need to create dummy variables, by all means do so. We have to take it 1 step at a time. I can't do this in the very first step. Okay, I'm not trying to say that it's not necessary. Did I answer your question?
Yeah, that makes sense. Thanks.
Okay, thank you. Okay, now let's go back to the task. So task O, we need to estimate a regression model, but this time we are not going to use T. Instead, we are going to use the group of dummy variables that we created. But once again, you only need to include 2 of them. If you include all 3 of them, just for the fun of it. So let me show to you the perfect collinearity example again. So those 3 variables are perfectly collinear. If you include all 3 of them in your regression model, what's going to happen is this. The software will automatically drop 1 for you. And this time it's picked 2. So you can choose which one to drop. And even if you don't do so, the software will take care of that. This is why I told you perfect collinearity is not an issue. It will be taken care of by the software. It's only when the collinearity is high enough to cause some problem, but it's not high enough for the software to take any action, then the burden's on you. Okay, so back to the window that we've done before. So that's a linear here you can decide which one to choose. So for example, if you only want to include 1 and 2, that will give you this result. So that works. And you may notice that both of them significant at 10% level, and R-square is not bad either. So that's a regression model by using dummy variables instead of a categorical variable as a numerical one. Okay, the last task we need to do is to estimate a logic model. So we need to create a variable. So for example, we would like, what we need to estimate is not exactly what the value of index, but we would like to predict. So for example, what is the chance for the index number to be beyond 103? So 103 is a cutoff point for us to create a dummy variable. So let's create a dummy variable. It's called index D. So it's a dummy variable based on index. So let's let it to be 0 first. Then you go back to do transformation, and that will be 1. So then if index moved to the right is greater than 103, so we change the value to be 1. So that's the condition. Click OK, and you go back, then double check whether the values are correct. So you compare the value of index, and so we can. So what I usually do is to go back to double check whether I did anything. Oh. So you can check index to see whether you did the right thing. So if it is greater than 100, greater than or than equals to 103, it's 1. Otherwise, it's 0. So that's the dummy variable you created. Now we are going to use this one as a dependent variable, which means we are running a logistic regression. So if you click Analyze and go to regression, this time it's not linear, but binary logistic, because you have a binary independent variable. So this time, put index into this box, and we use GDP and T as a covariate. That's the dependent variable. So you can click OK, and that should give you the regression output. And you can check whether they're significant or not, as we mentioned before. So that's question P and Q. That's the last 2 questions. The last question actually is prediction by using that logistic regression model we have just estimated. So let me get rid of the variables that we don't need. So we have those variables that we need, and you want to make a prediction when T equals 1, 2, 3, and GDP equals to 30 million. What you can do is here, manually input that. So 30 million, 1, 2, 3, 4, 5, 6, 7. So that's 30 million. And you can copy and paste, that works. So copy and paste into there. T equals to 1, 2, 3. Notice that we do not have any value for index and index D, and that's the idea. So if you go to Analyze, Regression, Binary Logistics, just as you did before, if you run this regression model, that will give you exactly the same result, even if you input the value for GDP and T for the last observation. Why is that? Because you do not have any information about the dependent variable in your analysis. So those 3 last variables, 3 last observations will be excluded. However, if you click Save and you check, so for example, probability, group membership, click Continue. And you can also click Options to specify what is the cutoff point. I'm going to show you what is classification cutoff point is. Now it's a 50% or 0.5. So continue, you can change it, by the way. So if you do this, you click OK. So that's the new regression output. Have a look at this output. So for example, the odd ratios are calculated, and that's significance value. And this is the model that we run in the last step. So they are exactly the same. Only difference is here is this the first box that summarized the regression analysis. In the first box shows to us we have 100 observations included in this analysis. There's no missing cases. But in the second analysis, if you look at this box, we have 100 observations included, but we have 3 missing cases. Those are the 3 new observations that I have just created. So they didn't enter into the estimation. It doesn't affect the estimation. However, because you ask the software to do the prediction, Well, it's possible to do the prediction because you do have the value for all the y, all the x's. So those are the predicted values, and that's the membership. Because this one is greater than 50%, that means the chance for this observation to be equal to 1 is higher than 50%. So we classify it as 1. So that's the predicted value. Notice that your dependent variable is a dummy variable, but the value that you calculated from your logistic regression model is a probability. So you always have to transform them into classification 0 or 1. So that's 2 steps of a prediction. And you actually have some control over this type of a conversion by choosing the cutoff point. If the probability is greater than 50%, then that's 1. If the probability is greater than 80%, then that's 1. So this is what we did before. Question?
Thank you. Another simple question. Could you define membership? I noticed that you clicked group membership and then you mentioned it. It's related to that PGR column. What does that mean?
A membership basically means whether it's 0 or 1. So notice that the dependent variable of our regression analysis, or this regression analysis, is 0 and 1. And your predicted value, look at that. What are those? Those are not 0 and 1. Those are the probability of y hat equals 1. Then you have this classification threshold, or you call it threshold. And if it is 50%, it basically means if this probability is greater than 50%, then chances are it will be 1, because that's the probability of y hat equals 1. Then you classify it as 1. Otherwise, if the probability of y hat equals 1 is only 23%, then chances are it's going to be 0, more likely to be 0. So you classify it in the 0 category.
Okay, thanks. I appreciate it.
You're welcome. Okay, so once again, logistic regression, when it comes to prediction, because of the nature of the method, it's not 1 step, it's 2 steps. You estimate the probability first. Then you use a cutoff point to transform and convert them into the 2 categories, 0 and 1, you're trying to predict. Because ultimately, you want to predict the value of index D, not the probability. Okay, so that's the last exercise in terms of SPSS. So let me quickly summarize. For SPSS, what we did was to have a quick run through, and you do have my handout. So just in case you need to go back to any exercise to make sure you know how to run the analysis. That essentially covered everything that you have to do for our project. So you open the Excel file in SPSS, you examine the data, you transform variable, you create new ones, you remove variables that you don't need, run a basic regression analysis, variable selection, add or remove variables accordingly, then run a test to check whether you can stop. That's it, it's the whole package. So do we have any questions before we move on to Stata?
Is there a sequence of tests we should conduct? I mean, should we conduct them in order?
Not really. I don't think that the order of those tests matters.
Because, for example, if I'm doing the reset test and I want to add some additional like higher order terms to my regression, maybe it will change the result of like heteroscedasticity test or.
All right, when you identify the problem, you're supposed to go back to the model to check. So generally speaking, if a model is adequate, it should pass all the tests. So it doesn't matter which one you perform the first. So usually when you add certain variables, it shouldn't create problem for the other tests. It should help. It may help you to pass the next test.
All right, thank you.
You're welcome. Well, my experience is sometimes if I add a higher order term, the missing one, an important one, a model that failed to pass the heteroscedasticity test and reset test at the same time, all of a sudden they can pass both tests at the same time because that higher order term actually solved the problem for both tests.
And what do we do if the higher order terms are not solving the problems? Because in the case of the reset test, I've done it through Stata and with square and the higher order term 2 and 3, it's still not answering the problem of the reset test. So what should I do? Okay, in that case, I would recommend you, for example, the reset test, usually you can pass that because it's just check of higher order terms. If you try anything in your capacity, still are not able to pass it, usually that's caused by omitted variable bias. And there's nothing that you can do about it.
All you can say is just a limitation of the data availability or the quality of the data. And you have to interpret my result with that in mind. No research is perfect. Okay, so the awareness of the limitation, of your result, and the effort that you made to try to solve the problem, those are the two things that matters. We're not looking for a perfect model because in practice, usually there isn't one.
Okay, it's very clear, but we can still add higher order terms, even though the research test is still negative. We can still add the higher order terms because it's, it helps specify the model.
If you have a very good reason, so for example, theory suggests that you have to have a square term. So for example, in the literature, it's well established. In most cases, you have to consider the square of a size of the house or square of the age, because they are not nonlinear. They are not linear related to house price. So if you have the justification, by all means include them. But if they are not significant, usually we don't.
Okay, thank you.
You're welcome. Okay, so that's SPSS. So let me switch window to.
Can I ask you a question?
Sure, go ahead.
So for dummy variables or interaction terms, I remember that there's multicollinearity issues. Do we still have to look at for instance, the VIF, even though we have dummy variables too? Or is it like looking at those kind of multicollinearity is important, even if we have dummy variables, or can we just like ignore that?
Generally speaking, if the multicollinearity, high VIF, to be put this way, if the high VIFs only exist within a group of variables that you created, for example, a dummy variable and its interaction terms, we usually do not consider that as a big issue, as long as you're interested in the overall effect, which means the effect of that group as a whole. But if you're interested in one of those variables specifically, separately, then that's an issue, because multicollinearity potentially, if it's too high, a bias is the coefficient estimate, which means the coefficient estimate of that single variable is not going to be reliable.
Okay, so within dummy variable, it's okay to have high VIF.
If it is a part of the group.
Okay, thank you.
You're welcome.